All right, let's get started. Good evening, everybody. Welcome to the December 2022 monthly meeting. Just to remind everybody, this is a business meeting. Hey, Trina, you taking notes? Thank you, Trina. She says from the back of the room. Well, let's get started. I mean, I don't have a lot to say. Welcome, everybody. Here are the board members as of today. And that's why we're here tonight. We're going to change a few of these positions around and add some new ones. So stay tuned. Here's our mugs, our faces. So here we go. Welcome new members. Are there any new members in this room in person tonight? Anybody new? One brand new person. Welcome. Welcome. And those of you online, welcome to you also. And I like to just take this time to talk about the club. I mean, the club is what you put into it is the way I see it. And the more you put in, the more you're involved, the more you get back. And you can get lots and lots back. There are so many people in this club that will freely give and share. And I mean, that's the way a lot of us are. Is if you ask a question and you thought it was just going to be a minute or so, you could possibly stand and talk to them for a half hour. I mean, it's easy. I've done it. So, and like I say, to kind of carry that farther is, you know, we could always use a few more volunteers. I mean, we have enough, but, you know, it would be nice if we could share the load of running this organization with a few other people. And there's, you know, I mean, there's other ways. I mean, I could poll these new members and go, hey, what kind of talents do you have, and can you get involved? But I don't really want to do that. I don't want to start that. But it'd be nice if you could just step forward and contact either somebody on the board, somebody at one of the sites. So if you're at one of the sites, I know ELO's got a star party this weekend. If you showed up there, you know, there's going to be certainly plenty of volunteers out there that if you're interested in getting involved out there, you can do that. There's the board members, there's the site leaders, there's the webmasters, all kinds of places to get involved. So I urge you to get involved. It's a great deal. It pays off. That's how I got to be in this position. Speaking of that, we just had a new member orientation. Steve and Rebecca did a fantastic job of creating. They did an in-person meeting, and then they so graciously agreed to have one recorded, and we recorded that using Zoom, and I edited it and I put it up on the YouTube channel, so it's there. And so check it out. I mean, even you guys that are members and have been members, you'd be amazed at how many things that you maybe have forgotten about that this club has to offer. So check it out. It's pretty cool. Treasures report. Our buddy Matt is on his way, sadly, on his way to a funeral out of state. And so think about him and his travels, and hopefully he has safe travels to and from. He'll get back to us next month. But the good news there, 678 members. That's 10 more than last month. I had to go back and look. I go, hey, that looks like last month's number, and no, it wasn't. It's 10 more than last month. So that's cool. Thank you, all you members. And I was looking at the new member list, and it looks like there was even an addition of a patron member. I'm just going, well, it's a lot of faith for somebody to just be new and join and become a patron right out of the gate. So thank you. I always like to thank the patron members. They give a little extra. My monthly thank you volunteers, in particularly all of you. I mean, all of you that have volunteered, whether you did something on your own, some kind of outreach event, something in the backyard, you know, you volunteered your time. But then there's the volunteers that show up, you know, the people that set up this meeting and got us ready for tonight, the people that are on the board, the people that are on all the site committees. And I know I'm forgetting somebody. Volts, I see Volts in the audience tonight, and he's, you know, he redid and got us a whole new website this year and new forums and all that. I mean, he wasn't the only one, but he led that charge. And then, in particularly, there's Steve and Rebecca. Like I said, they did that member orientation. We used to call it the new member orientation, but this time we called it the members orientation. It's for everyone. It's kind of cool. It was good. And then Gunnar spent just the last 2 years on the board. Gunner's in the room. 4. So Gunnar was on the board on the executive board for 4 years. So he gave 4 years of his time. That's a lot of time. A meeting every month just to talk about the business of running this organization. That takes time, and he took on projects that were assigned by the board that he volunteered for, and that he did. So those were all things that he did, and we thank you for that. Thank you, Gunnar. And tonight is so this is a business meeting. I just want to reiterate that, and it's a requirement of our bylaws that we call this a business meeting. We operate it like a business meeting, and at this business meeting, we're going to elect 3 new board members. Well, no, yeah, they're all going to be new because they're all going to be in different positions, even though one of them already is on the board. But we're going to elect 3. And I have a question. Do we have a quorum? I see there's 45 people online, and there's more than 20 in the room. We have a quorum. All right, let's move on. So we have 3 openings on the board: president, secretary, and the board member at large that is going to fill Gunnar's position as he's departing. I guess at this time, I would like to have those people that are those nominees come forward and introduce themselves. Who are you? Who are you, Trena Johnson? We'll let Dave go first since she's right here and he's got the mic. Yes. Oh, Dave, give Trena the mic. She came running up here.
Mine too?
There's no camera, just your voice.
What do you want me to say?
Who
Hi,
are you?
I'm Trena. I'm going to be your new president. Hopefully, I don't know. Vote for me, vote for the dog. Not sure. Or Mickey Mouse. There we go. And yes, if that's the case, you get to put up with me for 2 years. But that's all right. Hopefully, it will be fun and exciting and bringing the MAS Club into 51 years of modernism and female leadership. Thank you.
Hi, I'm Dave Falkner. Been a member for a while, been on the board a couple of times, so I'm familiar with how they work. Currently with the Cherry Grove Committee, and I like serving on the board because, as Trena pointed out, you kind of set the direction that the club is going. And so I'm very happy to be nominated for the secretary position, and I appreciate your vote. Thank you.
Hi, everybody. I'm Ahmed Reda, and I'm running for the board member at large. And I've been on the ELO committee since 2018. I've been coordinating the monthly meeting speakers for this meeting here since 2019, I think, early 2019. And I've, helped within the club in different capacities, like, the Camping with the Stars cookout, the 50th anniversary, trying to help Volts here with the website on and off. And I've been trying to help the club within my capacity. And I look at myself as hopefully by joining the board, I look at this club and I would love for it to be around in 50 more years. And I want to see us, how do we actually utilize our assets better for the members and engaging the members better in asset utilization. And also, how do we get the public to realize our existence, raise awareness and appeal for the club. So please vote for me. Thank you.
Thanks, Ahmed. And then Bill Ramsey could not be with us tonight. He sent me an email and said that he had double booked himself. So yeah, that's the way that happens, I guess. It's unfortunate. Oh, I need this thing. Why did I set that back there? So the way we're going to do this is everybody in the room that's a member, you have to be a member, should have a ballot, a paper ballot. Everybody online, can you turn the polling on? Uh-oh, I forgot to give you instructions. Walter, you logged in as president on Zoom?
I am,
Okay,
but it's on that.
Oh.
I'm not sure what you-
so go down and go down the polls. So hit launch. Don't hit end. No, you just hit close there. The X. Yes, yes. All right, so everybody, the polling is open online. You should have actually seen something pop up on your screen. And just go ahead and vote there. Well, it pops up on mine. It's on my screen. Should I vote here or should I vote on my paper one? So go ahead and vote. It's anonymous. I guarantee it because I set it up and I tested it and then I deleted it and had to come back and reset it up again. But I'm pretty sure I did it correctly. And besides that, I'll be the only one that even has access to that from here out. If there's any questions, post those in the chat and we'll monitor those there. That's all I got. You people that are in the room, vote and maybe get somebody to pick up your ballot. I'll take a moment to vote. As soon as I find my pen. I got it, I got it, I got it. I got it, I got it, I got it. Who's going to take my ballot? Don't look. Like I care. Okay. I broke it again. How does this happen? It's because I had to click, 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 click. There we go. So our next meeting will be back here again. We're going to do it hybrid again. I think we're going to continue that as long as the board decides that we're going to pay for the Zoom membership. How's that? Which I don't see us going away. I mean, I think that that is a great feature. If you miss a meeting, you can always catch up. Hey, I really wanted to see that speaker, but I couldn't be in person. I couldn't be at the meeting, but it's there. I can go to YouTube and I can see it. So I think we're going to continue that. At least that's going to be my recommendation. It's not like it's that much. We have equipment. We connect well into this space. We'll carry on. Sometimes. Well, yeah, never mind. Slack is out there for those of you that like to use it. It's, I mean, we kind of are running dual things with the forum and Slack. There are people that prefer Slack. There are people that prefer the forum. To each its own, I like to say. And I think it's great because the feedback is quicker, at least I think, on the Slack channel. I use the video feature all the time. If I have a one-on-one conversation I want to have with somebody in the club, it's great. You just get the two of you together at the same time, which is easy to coordinate on Slack, and you just hit a button on there and both of you are connected and off you go. There's no, hey, I got to send you an email with the link. You don't have to do that anymore. It's just and you can see when the other person is there. So that's really cool. You could share screens, you share audio, you share video. You can do everything. So I really love it. The MAS is on YouTube. The best way to find that is just search Minnesota Astronomical Society YouTube. And I haven't tested it on anything but my machine, but I've done it so many times. I just get MIN and it pops up. So you may have to, I think it works pretty well. So Anton is here to talk about the Lunar Scope program. John, we need a live mic. Anton, take it away.
Well, okay, as always, members are welcome to borrow one of our 16 or 17 lunar scopes. We have Dobbs, we have refractors, we have SCTs, we have a solar scope, we have a big pair of binoculars. So far this year, we've loaned out 86 times. And so of those 600 and plus members, an awful lot of you have taken advantage of the loaner program. You can make your request on our website under membership, under loaner scope. You just make your selection. That'll send a message directly to me. And I will get back to you when your telescope is available. We make arrangements for you to pick it up at my home. We also have these great courses, DVDs that you are also welcome to check out.
What's available today? Hey, Anton, I want a scope. What's available?
I have two 10-inch Dobbs. I think the refractors are available. And I have an SCT, but still, even though it's really cold outside, if you haven't noticed, it's cold. And there's still plenty of traffic in my driveway. People are still borrowing telescopes. So about at least half of them are still out. And I have several reservations waiting.
Excellent. Thank you, Anton. Terrific job as usual. How about applause for everybody for Anton? He does a fantastic job. You know, managing that many scopes in and out, you know, even in and out of storage, you know, when something has gone to storage, you know, he's got to go get it. And he takes care of that. So thank you. I'm holding it, but I'm still going to press the button on the keyboard. COVID, if you're sick, please stay home. Simple as that. Events before the next meeting. I think I'm just going to jump right to the really cool one. And that's the Mars is up at opposition. That's the really cool one. No, that's not it. Oh, wait, it's the full moon and the occultation of Mars by the moon. What is that, next Wednesday? Yeah, next Wednesday. That's correct, sir. And then that starts like around 9. And what's really cool is it's all done. So you can be in bed right after, basically right after the weather on Channel 9.
10:11 Central Standard Time.
Yep, 10:11. There you go. Thank you, Ron. And then there's you know, the meteor showers. The Geminis aren't going to be that good this year because of that moon, but they kind of stretch out a little bit. You probably can catch them a little bit before the moon comes up there last quarter. Those are always good. I have the Ursid. It's Ursid, right? They're not very well known to me. So I don't know what to expect. It just popped up on the list and I went, well, I'm going to add that because somebody probably will take note of that. You know, a meteor shower, it's cold. You don't want to drag your equipment out. Well, you don't really need any equipment to see a meteor shower. If it's clear and you can get to a dark sky, you already have all the equipment you need because all you have to do is look up. That's the best I can say. You know, you bundle up, you go out and you take your 15 to 20 minutes to get dark adapted, hang out for another half hour, see a few meteors, and go back in where it's warm. And then, of course, January 5th, we're back here again for the next meeting. Conrad, sir?
There is one thing that's happening tonight. Bob King posted. Jupiter and the moon are going to be in conjunction 2.5 degrees.
Okay. Conrad says that Bob King posted, MAS member Bob King posted that Jupiter and the moon are going to be 2.5 degrees apart at a conjunction tonight. So get out, check that out. Well, that's true. They are right now. Yeah. Just look up. Another one of those. Just look up and you'll see it. Oh, regarding see, I already spilled this whole slide. I guess I looked this up. It's 2209 at my house, Ron.
Well, it's considering the rest of the population.
That's true. I am a minority out there in Buffalo. It's just Mark Boyd and I that live out there in Buffalo, out there where it's dark. Ish, yeah. But there's a little picture there that I snipped off of Starry Night 8 Pro, and it's you can see. I mean, you just get an idea of size. Everybody knows, you know, the moon half a degree, you know, and then little Mars down there at 7.
I heard on the internet Mars is going to be as big as the full moon.
Yeah, it's close in 6,000 years.
Yeah, that's the other one. Did you know how close it's going to be?
And it's supposed to be as bright as the sun.
Yeah, right. Moving right along, You guys hijacked my presentation with that nonsense. Supplemented. So this weekend, there's a public star party out at Eagle Lake Observatory. It's a special event for the Mars opposition. It won't quite be at opposition yet, but it's close enough. The thing to know about that is it's only going to be canceled if it's completely cloudy. So if you're not sure, check the form. Merle said that he will keep that up and he will post enough advance warnings so nobody drives all the way out there and finds out that nobody's there.
So far, it looks good.
The forecast, I agree, the forecast looks good, and I've seen that before, to just take a turn. Now that we've talked about it, it's kind of like Fight Club. What's the first rule of Fight Club? Beginner Special Interest Group has a event this month, and it's going to be a Zoom presentation by Claire. Claire Weaverling. Her topic is going to be the winter constellations. The best way to get that connection to that Zoom meeting is go to the calendar on the MAS website, and the Zoom link is right there. It will be recorded, and somebody will download that and get that edited and get it back up on YouTube. So that will be part of our collection on YouTube also. So yeah, no pressure, Claire. Always, Father Brown always has a call for Gemini articles, because that's what we are. The MAS members contribute to that newsletter, and it's only MAS letters. Only MAS members that contribute to that newsletter. So, you know, I think that's really unique of our club that we have that, and it's really cool. And so, if you have something, hey, write it up, send it to Father Brown. I think he'll help you edit it if needed. All kinds of things, and it doesn't really matter. I mean, I think he's still looking. I think he'll still take stories. I didn't update my slide, but I'm sure he'll still take a story from some of you longtime members about what it has been to be part of this organization for the last 50 years. So I don't think he'd turn me back, put it that way, and say, oh, no, that was last month. But I did notice in the Gemini, when I looked through it just today, as a matter of fact, there's a lot of new people that I hadn't seen articles from or remember seeing articles from. So I thought that was quite cool. It wasn't just the regular gang writing articles for the Gemini. So maybe someday I'll sit down and do that. Someday, next month, maybe. So your weekly email updates, you know, we don't send it out every week, but how about everybody in the room, did you get that welcome email this week? Well, I learned that was an accident. That was an oops. But you know what? It was a good oops, because I can use that and turn it into something good. If you didn't get that email this week and you don't think you got it, maybe check your spam, see if it wound up in there. You know, but if you got it, good. If you didn't get it and it's not in your spam, then send an email to secretary@mnastro.org if you want to get those weekly emails, because that means you're not on the email list. That's, you know, that was a good test, even though it was unintended. You know, but you know, it's great. It worked out just fine because we use it as a tool. Anything to add, Trena? Oh yeah, Trena says when she sends these newsletter outs, she'd like you to read them. There's always good stuff in there, because otherwise we wouldn't send one. Astronomical League Awards. Jerry sent me a list, and he feels bad. He can't make it. But he had 3 awards this month. Claire, Binocular Messier Project complete. Pin received. You got your pin, right? Yeah, I got it. Oh yeah, look, she's wearing it. Yeah. And Trina got the sun spotter project completed. Did you get a pin? Oh, she has not received her pin yet. And Dave Tossenson, he's not here tonight, but I would like to hear more about that two in a view thing. I just give Jerry a hard time about two in a view. So Jerry's message, again, get out there and observe. There's plenty to see, plenty to do there.
Sunspotter program, that was really interesting. It only takes 2 months to finish, and you only have to have 20 good days to do it. Sketching, you'll learn how to sketch little black dots really well. But I would suggest doing it in the springtime. That way, over the course of 2 months, your sunlight increases so that you're not fighting it in shadows by 5 o'clock in the afternoon. Because that was fun trying to find places where there was no trees to block it out. So otherwise, it's great. Have fun.
Thank you, Trina. Oh, better know a constellation. Oh, a question in the group. Ron? So the question is what's two in a view?
Okay, the two in a view is where you have two deep sky objects in your same field of view in your eyepiece. So like you might have a galaxy and a globular cluster, or two galaxies, or something like that. Right? Yeah. I have to have at least two within your view in your eyepiece. You got to sketch it. And how many objects? Anybody know off the top of their head? There's probably like 50 objects or something like that you got to do. Yep.
So, Better Know a Constellation is up next. We are looking for a volunteer for January. Anyone? Anyone in this room? To present Better Know a Constellation. So, Better Know a Constellation is where you would pick a constellation and do some research and find out some really interesting facts about it. The mythology, what kind of objects are in it, you know, whether they're Messier objects or NGC objects or even some kind of obscure, cool, yeah, major stars. What are the brightest stars? You know, yeah, where it is. When can you see it? I mean, you'll see in a minute because Claire's going to do a presentation. And you'll get to see it because I already glanced. I already looked ahead. I've seen her presentation. It's fabulous. And there's lots of, she did a really good job. This would be, I'd say this is an example. And there's been others. Jerry took a different approach when he was doing it, where he would actually give you a little tour. He'd pick out a constellation or two and he'd give you a little tour on his iPad using software. However you want to do it. It's really up to you. This is an open time for you to stand up and contribute. So, any other questions? Here we are. Claire.
All right, so this will be an example of Better Know a Constellation. As Mark mentioned, don't you want to volunteer? I realized when I was looking at my slides yesterday that I had volunteered to do this in June. So this is my second time volunteering to do it within 6 months. So I think Mark promised like free beer and pizza at Old Chicago afterwards, right? for everyone who listens, right? Okay, so when I did the presentation in June, I did Delphinus, the dolphin, right? And then I realized I had picked Camelopardalis, which is a giraffe. And I'm like, oh, I think I'm stuck in a rut here of only doing presentations on cute animals in the nighttime sky. But that's actually not why I chose it. So the reason I chose Camelopardalis, some fun facts about it. Also, I like to create squirrel memes. So I was down at Cherry Grove this summer and working on various things. And one of the things I've been working my way through, speaking of Astronomical League programs, is the Constellation Hunter project. And on my list for that night was Camelopardalis. And I think I was expressing frustration, maybe trying to sketch this. And I made a comment to Trena, our president-to-be, and she said, well, you know that there's a mix of like obvious constellations and more obscure ones on there. And the purpose of that is to get you to look at the parts of the nighttime sky that you might not normally look at. And so I'm like, okay, I'm less frustrated now, like trying to sketch Camelopardalis, because it's forcing me to look at a part of the sky that I really actually don't think about and hadn't really thought about. So that's why I chose it. I know absolutely nothing about it. So it was fun to research. I'm kind of joking that it's invisible to the naked eye, but it's pretty hard to sketch. So, and it's not actually unpronounceable. It's pronounced pretty much how it looks, Camelopardalis. But I think upon first glance, I thought, oh, yeah, it just looked hard to pronounce upon first glance, but Camelopardalis is how I say it. I know that how to pronounce constellations can be a very heated source of debate within the club, and I don't want to get people riled up. So I did put the YouTube video on here in case anybody wants to dispute the pronunciation. Is there any, does everybody say Camelopardalis or? Oh, what, caramel leopards, okay. What would be another way to say it? Camelopardalis. Should we play the video and see what the robotic woman voice on YouTube says? I don't know if the sound will work. No, I think it's like Camelopardalis, Camelopardalis, Camelopardalis. But anyway, okay. Moving along. Oops, now we're not gonna. Okay, so where is Camelopardalis? This is kind of a smushed view on Stellarium, but trying to kind of make the point that on the one side, you have all your glamorous winter constellations. You know, you've got your Orion and Taurus and Gemini coming up there. And then you've got your circumpolar constellations there, the Big Dipper and the Pole Star and beautiful Cassiopeia and Perseus with its fabulous double cluster and all of that. And then right smack in the middle, you've just got a big hole where there's seemingly no stars, and that would be Camelopardalis. Right? It's a big black hole in the nighttime sky. And there you can see it with the constellation lines drawn in to just give you an idea. That totally looks like a giraffe now, right? Whoops. Okay, and so there we go with the animals, the giraffe drawn in. So you might think, well, okay, that's because light pollution, you know, but if you got out to a really dark site and you looked up at that part of the sky, you would totally see a giraffe. No, that's not true. The ancients did not have light pollution, and they did not see any stars or constellations in that part of the sky. So therefore, there isn't any Greek mythology that I know of associated with this constellation, and it wasn't one of the original ancient constellations. So it's relatively modern, which I'll explain in a second, but it does come from the Greek word for giraffe. And so how we use the Latinized version of that. So the word camelos, which means camel, and pardalis, which means spotted, because a giraffe was known as a spotted camel in Greek. So that's the name of it. So I mentioned it's really modern. It was introduced by a guy named Plancius in the year either 1612 or 1613 as part of a globe that was published in Amsterdam that year. And he attempted to introduce 8 new constellations that included, I can't remember all of them, but it was like the Bee and the Tigris and Euphrates River and the Jordan River and the Southern Arrow, I think, and I can't remember what all else. But of the 8, only 2 of them have come down to us in modern times as constellations that are still with us. And that includes Camelopardalis. I'll just say the spotted camel. And also Monoceros the unicorn. So those 2 are still modern constellations, and the rest of the things he introduced kind of fell off the radar. Okay, So here we are in our Milky Way galaxy in our solar system. And while it's not an interesting naked eye constellation, because we're looking out of the Milky Way and into other parts of nearby groups of galaxies, and also because we're looking slightly off the plane of our galaxy, there's actually quite a lot going on there in terms of deep sky objects. I was really surprised. So to just show you, I don't know if this is a comprehensive list, but just how many deep sky objects there actually are in that part of the sky. And you may notice galaxy, 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 and more galaxies.
I'm curious, what magnitude are you going down to there?
I don't know. I just, yeah, the ones I'm going to show you are like between 9th and 12th magnitude. So I'm actually not going to go over in great detail every single galaxy on this slide because we might be here all night. But just to give you an idea of like how many recognized deep sky objects there are in that direction of the sky. And then I chose ones that are, yeah, like 9th to 12th magnitude, and that are, speaking of Astronomical League projects, that are things that, you know, you might see in the Caldwell or the Herschel, or something like that. So we'll start with Caldwell. There are not any Messier objects in the spotted camel constellation, but there are 2 Caldwell objects, and the first one is Caldwell 5, also known as IC 342. And this one is magnitude 9. It's an intermediate spiral galaxy about 10 million light years away. And it's part of, it actually names that group of galaxies. It's in the IC 342 group, which our local group, it's one of the groups of galaxies that's nearest our local group. Also part of the Virgo supercluster. And the reason it got its name, the hidden galaxy, is because if it weren't for the fact that it's obscured by some of the dust lanes within our own galaxy, it would be quite spectacular in our nighttime sky. It would be right up there with Andromeda or Triangulum. It's face on, and it's about 2/3 the size of the full moon in our night sky. But because of the dust lanes that obscure it, it's got low surface brightness, and it's a little bit more challenging to find, therefore it's hidden. But it is still considered a binocular object. Okay, and then the other Caldwell is Caldwell 7, otherwise known as NGC 2403, also intermediate spiral, 8.9 magnitude, 8 million light years away. Also within one of our neighboring galaxy groups. This is in the M81 group. So where M81, M82 are located. And the interesting thing about this is you can see are the large star forming regions kind of on the outskirts of the galaxy in the outer spiral arm. And that one right there actually has its own NGC object within an NGC object, which is NGC 2404. Has anyone else done Caldwell? I know the Caldwell. Oh yeah, Chris has done it. You don't remember? Yeah, I didn't remember either of these either. Okay. All right, then there's some Herschel 400 objects in here as well, starting with 3 galaxies. 1961, another spiral, magnitude 10.9, 200 million light years away. This one was just interesting because of the highly, I think this picture doesn't, you can't tell as much as other pictures I looked at, but distorted and highly irregular kind of warped shape to it. And what's interesting about that is that they don't really know why. There's not a known companion galaxy, and it hasn't been part of any known mergers. So the shape of it is kind of interesting and mysterious. And then this one I just mentioned, this is part of Caldwell, and I just put it up here again. You can kill 2 birds with 1 stone, get both a Caldwell and a Herschel galaxy. And then finally, one that's not a spiral. This one is a lenticular galaxy, magnitude 10, 60 million light years away. And I don't know a lot about lenticular galaxies, but not a lot of star formation, no spiral arms, a big ball of kind of glowing dust. But Herschel described it as a very large, bright object to observe. And it's also a Seyfert galaxy, so it has an active galactic nucleus with a supermassive black hole in the middle. Okay, and this one is neither in Herschel or Caldwell, but I added it because I thought this one was pretty cool. And the name is nice, the Loner Starburst Galaxy. This one is in a dwarf irregular galaxy, magnitude 11.9, 11 million light years distant. And that core that you see is 5,000 light years across. This is part of the IC342 group that I mentioned earlier, but this is known as one of the most active galaxies in our local neighborhood. The star formation in this galaxy is 100 times that of our own galaxy. And it's been at it almost constantly for the past 100 million years. And so that gives it its interesting structure with these kind of cavities that have been blown out by young stars that, that burst as supernova. This one is also blue shifted, so it's coming toward us rather than moving away from us. Yeah. I just Googled them and looked at a lot of different images. And most of the ones I picked were like Hubble images. So I took them all myself, actually. No, I'm just kidding. I'm an imager about as good as Hubble, really. So yeah. Okay, and then speaking of galaxies, I thought this was also an interesting thing. So this is obviously not a galaxy that you're ever going to observe. This is one of two candidates for the most distant galaxy that humans have ever found. And it was found by the CLASH team, which stands for Cluster Lensing and Supernova Survey with Hubble. So they used the gravitational lensing technique to find a supermassive cluster of galaxies that they could detect, and then use gravitational lensing to try to find a galaxy even farther away than that. And looking at the redshift and trying to determine, so shortly after that happened, there was another candidate for most distant galaxy in Fornax that had an even greater redshift. So they're awaiting the James Webb telescope to tell us which of those two candidates is actually the most distant galaxy that we've ever discovered. And if the redshift is confirmed, it would be 13.26 billion light years distant from us. And that would put it back 427 million years after the Big Bang. And that is in the spotted camel constellation. I'm not going to say it anymore because Camelopardalis. Thank you. Okay, so there's not only galaxies. I decided to choose a few other things other than galaxies. I'll showcase two of the planetary nebula that are there. This one is called, it's IC 3568, but known as the lemon slice. And it's called that because NASA did a false color image of it, and it obviously just totally looks like a lemon slice. And the interesting thing about this one is that it's not really very interesting. It's actually one of the simplest planetaries that they've discovered. There's some structure to it that you can see with the Hubble, but if you were looking at it yourself through your own telescope, there's not much structure that you can see, and it's very spherical. And then another Herschel object, another planetary nebula that has a lot more structure to it. This one's called the Oyster Nebula. It's in the same region of the sky as the Heart and Soul Nebula, if you've ever observed that one. And this is interesting because it has an extremely hot pulsating variable star in the center of it that also turns out to be a binary. And it's so fast in terms of its pulsations that it significantly changes within half an hour. So it's very, very fast. And then some people have said it also kind of looks like a brain, so you could probably also call it the Brain Nebula. Okay, and then I haven't done carbon stars, But there are 6 carbon stars in Camelopardalis that are part of the Astronomical League Carbon Star Observing Program. I know Trina is working on that one. I don't know if have you done these yet? Okay, so these are on your list. Yeah. And do you want to explain what a carbon star is? Okay. What I know about them is that they have more carbon than oxygen in their atmosphere, which makes them luminous red giants that are very striking visually. These are not naked eye objects, but binocular or telescope objects. And then finally, I really don't want to spend too much time talking about open clusters, because if you know me from the summer, you know these are kind of the bane. Obscure open clusters are the bane of my existence, but I am working on the Astronomical League project, and these 3 are on my list. I haven't observed them yet. So 1502 is kind of a nice one. This one, Stock 23 Pasminos cluster, this one actually gets rave reviews from people who have observed it. It was kind of rediscovered by a guy named John Pasmino, thus the name, who wrote about it in a 1978 issue of Sky and Telescope. And this kind of brought it, I think it was kind of a rediscovery of this open cluster. And it's been described as very bright, obvious, easy to spot. And it's got some cool asterisms in it, a little trapezium and a little kind of torus shape that makes it actually really interesting. And then on the other end of the spectrum, you've got things like Tombaugh 5 that are, I don't know, this is my sketch of Tombaugh 5. Clyde Tombaugh, the guy who, I was going to say invented Pluto, the guy who invented Pluto. The guy who discovered Pluto when he was searching for trans-Neptune objects and combing over these photographic negative plates, he discovered 5 open clusters that are, I haven't observed them yet, I'm guessing really hard to find visually. And this is supposedly the best of the 5 in his catalog. So I have that ahead of me next summer. And there's more open clusters I'm not going to talk about. The only reason I put this slide up there is this Colander 464, which is thankfully not on my list. But this is somebody in Finland who was observing this one, and I thought their log sheet was hilarious. So it says, visually, there's nothing in here. About a dozen scattered stars, magnitude 6 to 8, stars colorful blue, white, red, and orange, but still total crap. So there you go for the open clusters. There's a pretty asterism there. That 1502 open cluster that I talked about, that one's at the end of this lovely chain of stars called Kemble's Cascade. I had never heard of this, but it looks quite lovely, and I'm probably going to check it out. You did? Was it nice? It was? Okay. Okay. And then just a final thought about Camelopardalis. Voyager 1 is headed exactly in that direction. There's a star called Gliese 445, and that's where Voyager 1 is headed. Obviously, by the time it gets there, it will be dead, and all of us will probably be dead. So it will be a long time in the future. But if Voyager 1 is drawn to Camelopardalis, don't you want to go out and check it out? So had to end on an adorable note. So. All right.
Test 1, 2. All right, that was fabulous. Thank you, Claire. Like I said, like Gunnar said, hey, can you do this again next month? No, I'm just kidding. No. 2 a year is great. Just think if everybody did 1, if every member did 1 a month, 668 months before you'd have to do it again. Our next meeting is January 5th. Happy New Year. So, Dr. Was it Vuk Mandich will be here. Or is he going to be here? Ahmed is going to be here or online? Ahmed is not paying any attention to me at all. Live or Memorex? Okay, stay tuned. But he's going to talk about gravitational waves. I'm super excited about that. I don't know anything about it, so I'm coming back. I want to hear all about it. So now, oh, hey, I have some news. I am not president anymore because we had a quorum. Trena Johnson, 75 volts. Dave Falkner for secretary, 75 volts. And the quorum number was 75. Bill Ramsey, 15 votes. Ahmed Reda, 59 votes. And somebody chose both of you, which invalidated his ballot. So congratulations, Ahmed. Welcome to the board. So that's that. We got that out of the way. Now on to the feature presentation. I'd like to present and introduce Dave Falkner, NASA Solar Ambassador, MAS member, and he's got a topic of Voyager after 45 years, the Interstellar mission. Give us just a minute to get.
Good evening, everybody. For those of you who don't know me, my name is Dave Falkner. I've been an MAS member for a while. I'm also a NASA Solar System Ambassador. Well, what is that? Well, I don't work for NASA. I'm a volunteer for NASA. We have several NASA ambassadors, NASA Solar System Ambassadors, who are members of the club. There's about 1,100 of us nationwide and a few scattered internationally. And our role is to go out and talk to the public about space exploration, and NASA missions in particular. Okay. And so I'm wearing my NASA badge and my MAS badge. Okay. So tonight I'm going to talk about Voyager 1 and Voyager 2 that have been in space for over 45 years. That's probably older than some of the people either in this room or online, but they are the oldest and farthest spacecraft that NASA has, that anybody has right now. Anybody has. And they're still operational, which is absolutely amazing. Okay. And I want to talk about the Voyager mission tonight, and let's talk a little bit about this. So I'm going to talk about the program itself, how it got started, talk about the planetary grand tour, and then the Interstellar mission, which is the extended mission that's on right now. I talk about where they are today and where they're going. Okay. So to start out, syzygy. This was the reason for Voyager. Okay, syzygy. The definition in the dictionary is 3 or more celestial bodies that are aligned. So, for instance, it would be like the sun and the Earth and the moon at a full moon. Okay, they're all kind of in line. NASA expanded that a little bit because in the mid-1960s they realized that they were going to have a very rare event, and that is to have all of the gas giants, all of the outer planets, the 4 gas giants and Pluto, all on the same side of the sun at about a 95-degree angle. Okay, this is something that only occurs about once every 175 years, so it's literally a once-in-a-lifetime occasion. And because of the alignment of the gas giants, it gave NASA the opportunity to send a spacecraft out with really very little fuel, and yet be able to propel it from one planet to the next using a maneuver called a gravitational assist, I'll talk a little bit more about, and be able to visit all 4 of the gas giants and potentially Pluto in record time. Okay, they figured if they'd be able to get to Neptune within 12 years by using this maneuver, if you sent a spacecraft at this time straight to Neptune, it'd take much longer, up to 30 years to get to Neptune. So this is really cool thing. So they called this the Planetary Grand Tour. Okay, and so they started working on this. The spacecraft that they chose for this was the Mariner spacecraft, or a variation of it. Mariner was a planetary exploration program that NASA had that lasted from 1962 to 1973 that explored the inner solar system, okay, like Mars and Venus, Mercury. And then what they did is they kind of upgraded it a little bit because we're now to the mid 70s, so we have high technology. And then it would have been like Mariner 11 and Mariner 12 that would have gone on this mission. But they also had to change the power supply on this. I mean, it was significantly upgraded to the point where they felt they needed to actually have a new name for these spacecraft. And so they named them the Voyager spacecraft. And the idea is that they're going to have two spacecraft, one that would pass by Jupiter and Saturn and then go on to Pluto, and then the other one would go by Jupiter and Saturn, and then Uranus and Neptune. Okay, so that was the original idea. That was the plan, but you recall during the Apollo program and the space race that the United States put a significant amount of its gross national product into the space program, and after 1972, they decided they were giving too much money to NASA. We needed to cut that down, and they slashed NASA's budget. NASA wasn't real sure that they had enough funding to be able to really do the total planetary grand tour. They prepared the spacecraft to do it, but they were only funded for a 5-year mission to Jupiter and Saturn. That was it. So they went ahead and created these spacecraft. This is what they look like. I'm not going to go into it in detail, but the spacecraft were designed to do the planetary mission. They had a magnetometer. They had some other plasma wave and cosmic wave type of particle wave to detect that. They had cameras. They had spectrometers, all the good stuff that you need to do planetary mission. They also had on it a different type of power supply because you can't use solar panels in the outer solar system because there's not enough light. So they had on board an RTG, okay, which is a radioisotope thermoelectric generator. This is a tried and true power source for NASA. They've used it on numerous spacecraft and also Mars rovers. It's nice because it takes heat and converts it into electricity. And the source of the heat is plutonium-238, okay? And they capture the heat from the decay of that radioactive material and convert that to electricity. And the plutonium-238 has a half-life of about 87 years. So it's a nice long-lived power source, and there's no moving parts. Okay. Now they had 3 of these on here. Where's my pointer? Here's my pointer. There we go. You can't see this online, but it's hanging off the end there. And there's 3 of them that produced at launch 470 watts. Okay. And speaking of launch, okay, the Voyager 2 was launched on August 20th, 1977. Voyager 1 was launched on September 5th, 1977. And you might say, that seems a little backwards. Okay, but it turned out that the trajectory of Voyager 1 was more direct, and they actually got it going faster than Voyager 2. So after a year, it passed Voyager 2 to become the lead spacecraft on this mission. Okay, and as I mentioned, the original mission was 5 years. So this is the trajectories you can see there that they had planned on this. And Voyager 2 would go by Uranus and Neptune. Voyager 1 would go out toward Pluto, but we're going to learn that was changed a little bit. It never did go by Pluto, and we'll find out why. That was planned. This is a little shot that shows how this gravitational assist works. You can see on the red line, this is for Voyager 2. Now, when it passes by Jupiter, it gives a nice big boost in speed, keeps going, goes by Saturn, gives another big boost of speed in Uranus and Neptune. So it maintains its velocity, even though it's continuing to travel farther and farther out in space. And so these 2 spacecraft are really booking along pretty well right now. And I'll talk about that in a little bit. As I said, by using this gravitational assist, it uses no fuel to do that other than just the fuel to maneuver the spacecraft, keep it on course, and maybe to turn the spacecraft to expose certain instruments. But really, that's all maneuvering stuff. That's not propulsion per se. The propulsion was done by the gravity assist. Okay. So let's talk about, I'm going to talk about the planetary mission, and unfortunately, I've got a whole presentation on this, but we're going to be talking about the interstellar mission too. So I'm just going to kind of hit some of the highlights that the Voyagers had as they went by each of these planets. Okay, and the first one is Jupiter. And when they went by Jupiter, a couple of things that they discovered that we didn't know anything about. One, in the top left here, you see that Jupiter has rings. We didn't know Jupiter had rings. We thought Saturn had rings, didn't know about Jupiter having rings. So that was a big discovery to begin with. And then as they were going around in the top right, this was probably the biggest surprise, was the discovery of volcanic activity on Io, the moon Io. The moon Io is roughly the same size as our moon. Our moon has been geologically dead for billions of years. Okay, and here's, you can see the plumes. This is a false color image, but the plumes coming off of the edge there of Io, active volcanoes on there. The two spacecraft photographed 9 active volcanoes on Io when they went by it. And so they figured out that what was happening was that Io's orbit, like most objects, is elliptical. So the amount of gravitational pull from Jupiter on that moon shifts as it goes around in its orbit, and it causes the interior to rub together, the tectonic plates, and liquefy. And so it remains like a lava inside, and thus we have the active volcanoes. The other thing that's discovered, let's go to the bottom left here. Voyager 2 got a very good look at the Great Red Spot, and we studied that as being a very complex and deep storm. Learned a lot of activity about, a lot of information about that particular storm. And then in the middle on the top there, that's Europa. And they discovered these fissures on Europa, which would normally be attributed to maybe tectonic activity, except if it's tectonic activity that would be pushing up, there'd be mountains and things of that sort, but it's a smooth surface. And they eventually realized that this is not really tectonic activity as much as cracks in ice, and that Europa has a very relatively thin crust of ice, and there's probably a lot of water, a huge ocean underneath Europa. Of course, that's going to be investigated a lot more with the Europa Clipper mission, which is going to be coming up here. They're planning that right now. Yes. Hang on. Yes.
Quick question.
Sure.
The rings of Jupiter, are they visible to the human eye, or is that an image of a infrared?
It's not an infrared image, but they're not visible from Earth, put it that way. Okay. You have to be close to the planet. In fact, you have to be backlit in order to really see them. They're very, very thin and delicate. Okay. Once Voyager 1 and Voyager 2 flew by Jupiter, and they realized, wow, we got some good science out of this. We got some great images out of this. These spacecraft are doing a fabulous job. NASA decided to go ahead and extend the mission. Okay. They went ahead and extended Voyager 2 to go beyond Saturn to Uranus and Neptune. However, Voyager 1, these two spacecraft were preceded by, a few years earlier, the Pioneer 10 and 11 spacecraft, which did flybys of Jupiter and Saturn. And when they went by Saturn, they realized that the largest moon of Saturn, Titan, had an atmosphere. And so with this upgraded electronics and detectors and the like, they wanted to do a much closer flyby of Titan to find out how a moon had an atmosphere and what was that atmosphere like and all that. So they changed the trajectory of Voyager 1 on its way to Saturn so that it could make a close flyby of Titan. But in doing so, it ruined the trajectory for it to be able to go to Pluto. So it would not go to Pluto by doing that. But they thought that was okay because Titan was worth looking at. So here are at Saturn. They got there, Voyager 1 in November of 1980 and Voyager 2 in August of 1981. They were able to make some detailed studies of the ring system. You can see here where they had the spoking on the rings. That was something that we couldn't see from Earth, and a unique feature. They found a number of moons, both in Jupiter and Saturn, smaller moons that weren't visible from Earth. They also found that Voyager, I believe Voyager 1, discovered this hexagon-shaped cloud top at the top of the North Pole of Saturn. Full disclosure, this is not a Voyager 1 image that's there. Once Cassini got there and got all the images, it's really hard to find Voyager 1 images anymore. You know, everybody wants Cassini images. So, but it persisted too, which is the other thing. So they've been studying that. And then, of course, on the far right, that's the atmosphere of Titan. And what they discovered by using spectrographic analysis and the like is that Titan actually has a nitrogen atmosphere. It's the only other object in the solar system besides Earth that actually has a nitrogen atmosphere. Most atmospheres are either carbon dioxide or hydrogen helium. And the brown color is caused by having hydrocarbons that are within that atmosphere. And hydrocarbons, of course, are the building blocks of life. So theoretically, if you could have some sort of organism that would be able to stand the very, very cold temperatures, you could have life on Titan. And there are such things as extremophiles that they've discovered on the Earth that live in very, very cold temperatures. So it's not beyond the realm of possibility. Okay, so Voyager 1 goes off, but Voyager 2 continues on to its next destination, and that's Uranus. Now, about the time, just before the launch of the Voyagers, there's an occultation of a star by Uranus. And when the star was occultated, they noticed that it winked a few times before it went behind Uranus, and then it winked a few times after it went by Uranus. So they realized that, oh my gosh, Uranus has rings, okay? Couldn't see them from the Earth, didn't even know they were there until that occultation. But then when Voyager got there, yes, in fact, it did confirm that there was a ring system. Its particles were very dark, and so it only reflected a small percentage of the sunlight. So, which is why it's not visible from the Earth. And Uranus is kind of unusual because, of course, it spins on its side. So the seasons are kind of weird. Half the year the North Pole is lit, half the year the South Pole is lit, and yet they still saw that the temperature on the planet was pretty uniform. So there's definitely some weather systems going on that's spreading the heat around the planet. One of the most interesting things they found was at the far right there, and that is Miranda, which is one of its moons. And Miranda has a surface that consists both of what appears to be older types of terraced rock and stuff, and then newer surfaces as well. And the two theories behind how it has that really disjointed surface like that is that either it's been torn apart and come back together at least 5 times to have a surface like that, or there's some sort of flow of ice coming up from the underneath that's flowing on part of the surface there. Not real sure. They need to have more exploration of Uranus and Neptune. And since Voyager 2 is the only spacecraft to ever have gone there, I support that idea. They went on to Neptune. At Neptune, they discovered that Neptune itself had a ring system as well, very delicate. There was some indication from Earth occultations and the like that there might be a ring system there, but there was nothing that was conclusive like Uranus was. But when Voyager got there, it definitely saw that ring system around Neptune. So we now know that all 4 of the gas giants have ring systems. In addition, it has some clouds and storms, not unlike Jupiter. They call it the Great Dark Spot. It's about the size of the Earth, and it's a big storm on Neptune. Unlike the Great Red Spot, though, however, it wasn't as persistent. When they went to look for it again with the Hubble Space Telescope in '94, that spot had pretty much gone away, but new ones had formed. So it seems to be a little more of a cycle there. Again, they don't know a whole lot about that, but these large dark spots do occur on Neptune as storms. And then top left there, that's Triton. That's the largest moon of Neptune. And it has a rather unusual surface too. They describe the bottom part of that surface as cantaloupe-like. Okay, it looked like a cantaloupe. They also noticed that there was actually cryovolcanic activity on Neptune as well, which would be like nitrogen spouting out from volcanic-like features on Neptune, on the moon rather, on Triton. Okay. So Voyager 2 flew by Neptune in August of 1989. And then when it was finished, it went off into the great unknown as well. So now we have the 2 Voyager spacecraft. We have Voyager 1 that's on a trajectory that's about 35 degrees above the ecliptic plane. And we have Voyager 2 that's going at about 48 degrees south of the ecliptic. So they're going off in 2 different directions. And Voyager 1 is traveling at about 3.6 astronomical units per year. For those of you who aren't familiar with an astronomical unit is the mean distance between the Earth and the Sun, about 93 million miles. Okay, we'll be talking about astronomical units again. So, so Voyager 1 is going about 3.6 astronomical units per year, and Voyager 2 at about 3.3 astronomical units per year, a little bit slower. Okay. This actually turns out to be pretty good because with their traveling off in different directions like that, when they start exploring the heliosphere, they'll be able to see the heliosphere from 2 different perspectives, and it helps them to kind of understand the shape and the nature of the heliosphere. So once they finished their planetary grand tour, we had 2 spacecraft that were fully operational, but the power supply was going to last a lot longer. So they decided, let's go ahead and have these 2 spacecraft continue on to what they call the Voyager Interstellar mission. And the idea behind that was that they were going to explore the heliosphere, which is that part of our world where the sun's influence exists. But at some point, there's going to be a barrier between the sun's effect and interstellar effect. There's going to be some barrier there. Okay. And so they wanted to have the Voyagers explore this entire area and get into interstellar space and find out where these barriers are and what they look like. On February 17th, 1998, Voyager 1 passed Pioneer 10 as the most distant human-made object in space. It would take about 15 years for the Voyagers to reach the edge of the heliosphere. So I'd like to talk a little bit about the detectors. Okay, so once they finished the planetary mission, they took a couple more shots back at the solar system, but then they to conserve electricity, they shut down a lot of the systems. They shut down the cameras, they shut down the spectrometers. They really weren't of any use at this point. But they kept on with these instruments here. There's a magnetometer out there, which is measuring the magnetic field. The cosmic ray subsystem. Cosmic rays are high energy rays or particles that are generated from supernovas and are in interstellar space. Plasma science. Plasma you can equate to the solar wind. That is plasma. And then there's a subsystem antenna down there. And then there's a low energy charged particle instrument, which is kind of the bridge between the cosmic ray and the plasma ray. So those are the key instruments that were used for this next phase of Voyager's mission. Now, talk about that. Let's talk a little bit about the sun. I know you guys know a lot about the sun. We're just going to touch on a couple of aspects of it. As we know, the sun, our closest star, is plasma. Okay, and what is plasma? Plasma is the 4th state of matter. You have solid, liquid, gas, and plasma. Plasma being disassociated electrons and protons moving around because there's so much heat. And this plasma, boils up from the center of the sun and continues to move out, and then it continues to move out from the sun. The sun shoots it out into space at about 1 million miles per hour on average. Okay, in some cases it's more. We'll talk about that in a second. Okay, obviously the sun's huge. We know about that, and because it is plasma, you have this dynamo effect, which is what of course, the Earth has a dynamo effect as well, with the liquid molten core of the Earth and the solid iron core, and the differential rotation between those two causes an electric current that creates a magnetic field that goes around the Earth. The sun is much larger, and it has a differential rotation as well. So you have this plasma moving at different speeds. It's creating a lot of currents and a huge magnetic field as well. It's generally speaking a bipolar field. It extends way out, okay? And so we'll talk about that. It does have a north and a south pole that flips every 11 years with the sunspot cycle. And the reason that it flips is because of the differential rotation of the sun. This shows the magnetic fields, and as the sun rotates, the equator of the sun rotates at about once every 25 days or so, and closer to the mid latitudes and the upper latitudes, it's more like 35 days. And so this causes, you know, the magnetic field to stretch and wind around the sun and get you know, tighter and tighter. And in order to relieve the stress of the magnetic field, sunspots occur with their own magnetic fields, and they relieve this magnetic stress and reset the sun, and also it flips the poles of the sun. Okay. We're probably familiar with this diagram, the butterfly diagram. Typically, sunspots start at mid latitudes and then begin to grow and have more and more in population, and they move more and more toward the equator of the sun, and then they complete the cycle. You get a little bit of a quiet period, and then you start seeing them at the mid latitudes again. And we see the sunspot cycle down here. It's definitely every 11 years, although it varies in intensity from 1 year to the next, or from one cycle to the next. Okay, so we have the plasma and we have the sunspots. The other thing that we have, of course, are solar flares and the coronal mass ejections, things that tends to shoot out the plasma at a higher speed. A coronal mass ejection can shoot out this plasma, this solar wind at about 3 times the normal rate, so about 3 million miles per hour. So the solar wind is not consistent. It varies a little bit depending on the frequency and the location of these various storms and cosmic and coronal mass ejections and the like. Okay, so what scientists believe was that this solar wind goes out, and they called it supersonic, which I looked up the term. It's a little misleading because there's no real medium per se, but it's coming out at 1 million miles per hour and does continue to slow as it moves farther and farther out into space. And at some point, it will drop subsonic, they call it, but it drops below a certain speed, continues out, and then will hit some sort of barrier between the effect of the sun, called the heliosphere, and the interstellar medium. Okay, and so this is what they expected to see. At the point where this plasma drops down to subsonic speeds, as they say, is called the termination shock. And then the heliopause is that area, that barrier between the heliosphere and the interstellar medium. And that's what we're investigating. One of the things that they also expected, so they expect to see a couple things here. One, obviously, when we move from the heliosphere to interstellar space, there's going to be a drop in the solar wind. There's a drop in the plasma particles, the number of those, and an increase in the cosmic particles in the interstellar space. The other thing they expected to see would be a shift in the magnetic field. The magnetic field of the sun travels out all the way to the heliopause. And they expected to see that the magnetic field that's in interstellar medium caused by the cosmic wind, if you would, and activity out there is different than the magnetic field that's in the heliopause, and they expected to have some changes there and shifting of the magnetic field. And the shifting of the magnetic field at that point would cause a barrier that would allow particles to move from one to the other. So here's a change in the magnetic field from the interstellar wind and from the solar wind, and that would open up little channels for particles to go through that they called the magnetic highway. So that's what they expected to see. And in that magnetic highway, you would see solar particles flowing out into interstellar space, cosmic particles flowing into the heliosphere. That's what they expected to see. As Voyager traveled out, it did hit. I'm going to back up just one here. It did hit the termination shock, where the wind dropped from supersonic speeds to subsonic speeds, and that happened at let's see. Well, they expected it to occur around 94 astronomical units. Yeah, they did. Okay, in 2004, Voyager 1 crossed the termination shock as indicated by the solar wind dropping at 94 astronomical units, or about 8.7 billion miles. Okay. And Voyager 2 crossed that same boundary a few years later. As I said before, it was really nice to have the two spacecraft traveling in different directions because they can kind of define the shape of this. The sun is traveling through space. And so it's not just a sphere that's around us. It's more like a teardrop as it's traveling through space. And they get this bow shock in the front where, of the direction of travel of the cosmic wind that's building up a little bit. So one of the things they noticed as it got past the termination shock and out closer toward the heliopause, the magnetic field was pretty consistent up to that point. And then they found that as they approached the heliopause, there was an increase in the magnetic field. Okay, and the reason that they feel it was this way is because at the heliopause, the magnetic field was bouncing back, and there's kind of an interference pattern there. And that caused an increase in the magnetic field. And they also noticed that there was quite a bit of turbulence in this area as well. So you can see at the bow shock here, there's this buildup of stuff there, and I've got a little thing here. And they called this the froth. Okay. And it is magnetic froth. So each of these is kind of like a magnetic bubble that's in there. And as Voyager went through that, it could sense the change in direction of the magnetic field through this whole frothy thing. And they're actually fairly large. They were measuring them as being about an astronomical unit across. So it'd take them, a few months to cross each of these bubbles as it was crossed. But they felt that just because they were hitting this magnetic froth, they hadn't entered interstellar space yet. It's just a condition that occurred near the boundary of it. They also found that the detection of cosmic rays in here, the magnetic field, this froth, tended to change the direction of the cosmic rays a little bit. And so it took away a little bit of their energy as they came in. And it was one of the ways that the sun's heliosphere helps to protect us a little bit from the cosmic rays, because those are high energy rays, which can actually hurt you. So where am I here? No, frozen on this side. Great. Okay. So this is a good diagram that shows the magnetic field and then the froth. You'll notice that we'll get to that in a minute. Let me get this. Okay, so we've seen where Voyager 1 has gone above the plane, and is actually that area up there called the solar apex is the general direction that the sun is traveling through the galaxy. And so that was where the buildup is of the solar wind and most of the froth. Where Voyager 2 came down, it's if you think about a ship moving through water, it kind of builds up at the bow. The Voyager 2 is more along the flank, and the froth was not nearly as thick there. And Voyager 2 noticed that there's also seemed to be a leakage of solar wind going out into interstellar space as a result of that. Okay. All right, wait a second. I got to get this guy up to speed here. Okay. Nope. This one here. Okay, so just to review, the three things that NASA was looking for to indicate that these spacecraft were exiting the heliosphere and going into interstellar space was the reduction and eventual elimination of the solar wind, the increase in cosmic radiation, and then this change in the local magnetic field as it passed through. Okay. So the first thing that they found, they finally did see that there was a change in Voyager 1. I remember this particular occasion. It happened in 2012, and it reached the barrier, and we could see that there's one one part that came down here. Got an arrow on here? Yeah, I do. Okay, cool. So you can see this first one where it dropped way down. And I remember that because they came out, we have a big drop in the solar wind. Voyager is passing through the boundary. Okay. And then it went back up again to the same level it was before. Wait. Didn't quite make it there. Hold on. We're not there yet. Okay. And then it dropped again the second time. It said, oh, yeah, we made it now. This is it. And then it went back up again. They said, wait, didn't quite make it. And then it finally went down and it stayed down. Okay. And then they knew then that it did actually finally pass through. A couple things about this. Number one is that kind of shows that this boundary, this heliopause is not, a stationary thing. It ebbs and flows a little bit. Okay. And it ebbs and flows because the solar wind coming out from the sun ebbs and flows, right? It generally starts out at about the same speed, but remember you get these the coronal mass ejections, you have flares and stuff. The solar wind itself fluctuates. And so as a result, the heliopause fluctuates too. Okay, that's why they got that. And they also saw the corresponding increase in the cosmic ray particles. So they were fairly certain at this point, finally in October there of 2012, that Voyager had in fact passed through that barrier between the heliosphere and interstellar space. Okay. Going back. Whoa, Dave, what'd you do? Wow. Hang on. I hate touchscreens. Okay, here we go. I hate touchpads. All right. So a few years later, we have higher technology, so we actually get moving diagrams instead of stationary ones. Anyway, 2018, we saw Voyager 2 make the same transition. Again, there was kind of a dip there, you see, especially in the galactic cosmic rays, but you can also see it in the bottom graph of the heliospheric particles. It wasn't a straight go out. There were some bumps there because again, the heliosphere is moving around a little bit. And by seeing when it did leave, because it knew how fast it was going and the trajectory that it was on, along with Voyager 1, it also helped to verify that the shape of the heliosphere, at least from 2 points. Okay. So now we have both spacecraft. Now, one of the things that they didn't see, which was really kind of a surprise, was that when it went through and they measured the magnetic field, they found that the magnetic field in the heliosphere and the magnetic field in interstellar space aligned. They weren't different. They weren't opposite each other. They were actually in alignment. And they do not know why this is, but it was a real surprise to them that the two magnetic fields seemed to align for some reason. They're still figuring that one out. Okay, so where are the Voyagers today? Okay, I took this status as of mid-October of this year. Voyager 1, 14.7 billion miles from the Earth. That's 158 astronomical units. To give you some idea of how far away that is, obviously radio waves travel at the speed of light. One-way transmission takes 21.5 hours to get to Voyager 1 and 21.5 hours to get back. So when they send some sort of command to Voyager, it's almost 2 days before they even know if it got it, let alone executed it. Okay. Voyager 2, not quite as far, had 131 astronomical units, only takes 18.25 hours for radio transmission to get there. I am an electrical engineer by education. I think this is absolutely unbelievable that we can even detect them out that far. You know, this is a little spacecraft. It's got a little transmitter, and yet we can still communicate with the spacecraft. Most of the scientific subsystems that were left on are still going. All of them are on Voyager 1. The plasma science instrument on Voyager 1 is not operational anymore, but in Voyager 2 it's operating. And of course, their communications and their RTG. However, as the RTG goes on, yes, it has an 87-year half-life, but the amount of heat that it generates continues to drop. Okay, and so the feeling is that by 2025, it's probably not going to be able to generate enough electricity to maintain communication with Voyager. quick note, you talk about the computers, the amount of memory in your phone, about 200,000 times more than what's on Voyager. So there you go. Where are they going? Okay. Where am I here? Okay, so Claire alluded to this. Where are they going? This is a graph that's astronomical units. It's a logarithmic graph. You can see they're 10 to the 2 is 100, so they're just past 100, just past the bow shock there, heading out that direction. Okay, so what we got here? So this is a graph that kind of shows the movement of the stars in our general neighborhood of the galaxy. And you mentioned Gliese 445, right? Okay. Okay, so in 46,000 years, Voyager 1 will be at 1.5 light years from Gliese 445. Okay. All right. And Voyager 2 is heading out too. In 46,000 years, it'll be near Ross 248. Those are two very famous stars. I'm sure we're all both well aware of those. So let's pick a star that we actually know about. Sirius. Voyager 2 is actually going to travel. Voyager 2 is actually going to travel within 4.6 light years of Sirius. It's only going to take 296,000 years, but it's going to get there. Okay, so here we have these spacecraft traveling on interstellar space. So what happens if an intelligent society actually stumbles onto one of these, right? Okay. Well, both of them contain identical golden records. Okay, this was the brainchild of Carl Sagan. Okay, and the jacket of the record, and then included a stylus in there because it is a record, and it explains in the top left there how you play the record. Okay, with the stylus and all that. It's designed to be played at 16 2/3 revolutions per minute. On the right side there is the way that they encoded images on here that could be created raster style, like in the old TV sets, and build pictures. Okay, and they explain how that happens on the right side up there. On the bottom left here, that star-shaped object, that is actually our sun and 14 pulsars with they encoded in there what the pulse rate of those pulsars are, because theoretically, if you know where those pulsars are, you can identify them by their pulse rate. You could triangulate back to the sun and to the Earth as a result of doing that. Okay, and on the bottom right is a model of the hydrogen atom, because they wanted them to know that, oh yes, we understand that most of the universe is hydrogen. Okay. They also electroplated onto the surface of the jacket here a very pure source of uranium-238, which has a half-life of about 4.51 billion years. Okay, and so if they detected the uranium on there and detected the daughter elements from that, they could theoretically at least get a shot of how old the spacecraft is from that. Okay. Inside of this is the golden record. It's actually a copper record that was gold plated. Okay, and on there are 115 images, as I described. The remainder of the record is audio, and it has 45 greetings in different languages, or excuse me, 55 languages, greetings in 55 languages, nature sounds such as surf and thunder and wind and animal noises and all that stuff, and then 90 minutes of eclectic music, including Eastern and Western classics, as well as a variety of ethnic music. And of course, as everybody knows, the first Star Trek movie was all about them finding a Voyager and then coming back to Earth with it. That was Voyager 6, which doesn't exist, of course. So that's it. Any questions?
Yeah.
Back here.
Wait.
Wait. Right back there. Dean, back corner.
No, that isn't how it works.
Am I on? All right. My question is, we frequently get asked, like, how far away is the nearest star and how long it would take to get there when we do outreach type events. And I usually tell people that if you were going as fast as the fastest Voyager, it'd take you about and I'm always a little mushy about this, somewhere between 70,000 and 100,000 years to get to the nearest star, which would be Alpha Centauri. Am I anywhere close to correct?
Well, I'd have to do the math. Okay, we're talking about roughly 3.6 astronomical units per year. Okay, you figure out how many astronomical units to Alpha Centauri and figure it out. Yeah.
Yeah, if you're doing 25,000 miles per hour like Apollo, it would take 114,000 years to get to Proxima. Like so the fast and change.
Yeah, but Voyager's traveling faster than that.
Right, but I use Apollo because that's how fast people want to go.
Okay.
And people don't give a
All
crap.
right. So Apollo traveling and 25,000 and how many years?
114,000 and change.
114,000 and change if you're traveling in an Apollo spacecraft. Oh, okay. We have something on the board here. I heard that Voyager computers use at least partly COBOL as a programming language. I don't know that for sure, but it wouldn't surprise me. That was Fortran? Oh, Fortran. A lot of Fortran. There we go. What's this? I don't know. Going up, there's other ones. Oh, here. The origin of Voyager 1 planned Pluto flyby. Do you know the ETA they expected had not been tightened? I do not know that.
It's right there. Ben answered it.
Oh,
1986.
oh, March of 86 would have been it. Okay, there you go. See, there's people smarter than me.
Thanks.
Oh, but nice job, Claire. All right, yeah. Okay. All right. Any other questions in the room? Any other questions online?
One online, please.
Yep, one online. Go ahead. Go ahead.
Mark here. A bit of question about the, basically we call relative speed of the spacecraft. Is there any expected aspect that it might change due to anything out there? Because I do remember the PBS series Nova, the series about the universe and such, and they reported that they found recently a number of exoplanets that are sort of flying around between solar systems. And I'm wondering, any gravitational perturbance like that, would they expect changes in some regards to the flight path? Or considering it's now?
It would have to come pretty close. And I have my friend Ron here who could probably say that. But yes, there are. I think we're fairly certain that there are planets floating in interstellar space. And if the chance occurrence though would have to be almost a collision course for the gravity from an object like that to affect Voyager enough to change its direction or accelerate it.
Thank you.
Yep.
Anyone else? Oh, yes, Mark.
Yes, the original project scientist was Edward Stone. He's 86 now. He just recently retired.
I believe that.
Up to this point, he was the only project scientist on the Voyager missions.
Yeah, no, isn't that amazing? Yeah, to have that kind of dedication and to stay with it for that long.
By the way, if you can find anything online, like on YouTube, with Ed Stone talking about Voyager, sit down and watch it. He's an amazing character, and he's such a slice of that era when the Voyagers left, and he's got so many stories. If I could get that guy in a bar for a couple of hours, yeah, he's an amazing character.
Yeah. Okay.
Anything? Anyone? Online? Hey, thanks, Dave.
Thank you.
Good job. So that's a wrap. See you next month. Happy holidays, Merry Christmas, Happy New Year. And those of you in house, we're got reservation over at Old Chicago if you're interested.